Now hang on. What are we all talking about? We're talking about electric, connected, shared, autonomous. When I look at the traffic outside, all around the world, it's a mess. Particularly in Tel Aviv in the morning, it's a jungle out there. So we heard that there are 4 pillars. We learned about autonomous driving. The technology exists, but where is it? How do you implement all this? Well, patience, my friends. Before you learn to run, you must learn to walk. Before you eat the hummus, you need to learn to wipe it with a pita. So, autonomous driving, the road to implementation. Please welcome Sudhir Mehta, Chairman and Managing Director, Pinnacle Industries Limited.
Good afternoon. Can I request all the other panel members also to join me on stage? So very good afternoon, ladies and gentlemen. Let me welcome you to the panel on autonomous driving, the road to implementation. I can see that several of you chose us over an afternoon cup of coffee, so thank you for that. I'm sure the rest of the audience will be joining us shortly. I'm told this is one of the hottest topics of this conference, and really one can understand why. The automotive industry globally is at the cusp of a major transformation, and many technologies which actually were conceived decades ago are now coming into the realm of reality. Autonomous driving and its path to implementation will see the creation of many superstar companies, startups, entrepreneurs, and along the way many fortunes will be made and lost in this journey. Let me start by requesting each of our distinguished panel members who are here from all over the world to introduce themselves and give a short introduction on their company, please.
Hi there, my name is Richard Porter. I'm Director of Technology and Innovation at Meridian Mobility. Meridian is a part-funded government, part-funded industry company in the UK, and it's our job to accelerate the delivery of connected and autonomous vehicles and the benefits associated with them to the UK. Currently, we're invested around £140 million into test and proving grounds, which cover city environments, highway environments, public parking environments, and rural environments to create a really comprehensive ecosystem whereby you can turn up and test and move flexibly between these capabilities. We're also investing in a data exchange to enable companies to exchange data about trials and testing, potentially to build future business models, and we're looking forward into the future to what do we do with government and industry around cybersecurity and simulation. What are the opportunities there? How do we use those to develop better standards, better best practice to accelerate the delivery and the benefits to society of these technologies?
Hi, I'm Danny Shapiro. I'm the Senior Director of Automotive at NVIDIA. We're based out in Silicon Valley, California, but we have global operations. We have teams here in Israel and throughout Europe, throughout Asia. We're focused on building the whole infrastructure for the autonomous vehicle revolution. So not just what goes in the car, the hardware and software, but everything that traces back to the data center for training neural networks as well as simulation. So thank you again for the invitation to be here. It's great to be part of the panel.
Hi, and I'm Pat Jameson. I'm actually stepping in for my CFO, Brandon Eldredge. But I do work for APTIV. I'm the Director of Strategic Investments and manage our minority investments portfolio. APTIV is a global technology company that is helping to really push the automotive sector into a greener, safer, and more connected future. I think at the highest level, we innovate around the brains and the central nervous system of the vehicle through our advanced safety user experience segments, as well as our signal and power solutions segment. And over the course of the last few years, we have really built up a nice kind of businesses with acquisitions of Automatica, Autonomy last year, as well as Control Tech and Movimento to really kind of make some really good strides on really delivering innovation for the future. So self-driving cars and really the connected car of the future, which we'll get into here in this panel. So thank you for having me.
I'm Chris Leck from the Land Transport Authority of Singapore, or LTA, and LTA is essentially the regulator in Singapore for all land transport related issues. Of course, one of the areas that we are actively coordinating as part within the Singapore government as well is AV deployment activity. So LTA serves as the coordinator and really driver of AV deployment within the Singapore context.
Thank you, Chris. Danny, let me start by you, and if you could kindly give us your opening remarks.
Sure. We'll switch onto this mic. So I was asked to kind of just give a little bit of a framework for the underlying technology that you all, my fellow panelists and some of the other speakers, essentially are using to create this autonomous future. And there's a really essential and fundamental aspect of everything we're all talking about, but it's safety. How do we ensure that these vehicles we're putting on the road are safe, that will do no harm? And at the root of all that really is computation. We're putting computers in the car, we're putting AI computers in the car, and this is really indicative of this fundamental shift that's happening across every industry, where the CPU, the traditional computing horsepower, has flatlined. Moore's law continually gave us more and more compute every year, and that's come to an end. And now the GPU, with its parallel processing, and now as an AI processor, is taking off where the CPU has ended, essentially. And so these parallel cores are used to process data and create systems that have superhuman levels of perception. We've heard a little bit about that. But now the data is writing the software as opposed to engineers. We believe everything will be autonomous. I think we were talking about shuttles, buses, cars, and there's multiple levels, of course. But the fundamental technology, whether we're talking about a level 2 or level 5, is the same. It's the sensor arrays, it's the data coming in, and the AI that's processing it and making great judgments. But I think what we haven't really addressed, and this is an opportunity now to kind of broaden the focus of our discussion, it's not just what's happening in the car. You make a car computer for that. It's a supercomputer. It's able to process hundreds of trillions of operations every second. But before that, these neural networks have to be trained. So there's an amazing scale out that's going on in the data center. And then, before we even put it on the road, we have the ability to simulate all kinds of scenarios and hazards. We can test and validate it before we even put it on the road. So one of the things I wanted to showcase just real quickly is you look at the bottom video here, there's 10 different neural networks that we have running in the car at once. So we're able to identify objects, we can identify the free space, we can sense distance, we can process LiDAR, we can process radar. It's really this diversity and redundancy of different kinds of algorithms, processing different data on different processors inside the car that gives us that extra level of safety. And so we're running on thousands and thousands of different conditions and locations to test these algorithms. If you look at it, we have a small fleet compared to many other customers of ours. But we're developing the core technology, we're not developing the vehicles. And so we need to understand what our customers are doing and how to create the hardware and the software for all these types of vehicles. And so we have a small fleet, we're driving around, we're collecting petabytes of data, massive amounts of data that we're using to train. We also have over 1,000 people that are labeling the data, so it's a manual process to label the data sets for training, and then thousands and thousands of GPUs that are being used to train these neural networks, as well as using simulation as a way to test and validate. So this is a huge big data problem that the industry is facing. What I wanted to show here quickly is a video of one of our simulations. So this is a basic NCAP test, so New Car Assessment Program testing emergency braking. Now this is an actual course of action research out in the UK, tests this, it's an abandoned airfield. And so what we're able to do is actually take all the data that would come from cameras, radar, and LiDAR, simulate that, feed that into the algorithms, and be able to test our system. So we can do this on closed courses, we can test this on highway, getting actual mapping data, and be able to assess, do these systems work? The actual hardware and software that's going into a vehicle on the road is first able to be tested on millions of different scenarios, different weather, different conditions in the data center. So the last thing I want to show you real quick is a test we did recently in Silicon Valley. So in the center there is one of our test cars, and it has radar, LiDAR, number of cameras on it. And we did a Silicon Valley loop. So we drove 80 kilometers, if you're familiar with the area, up 280, 92, down Highway 101. We're merging, we're changing lanes. Here you can see different algorithms as we're processing. And again, many different neural nets running simultaneously to understand the environment, detect lanes, detect other vehicles, to understand, again, what's going on. Here you see the combination of simulation on the left, the actual driving on the right, and so we're able to photorealistically create an environment, introduce all kinds of cars and variables into it. So again, I think the combination of training in the data center, simulating in the data center, and deploying in the vehicle is part of this enormous computational task that I think we can all discuss now as we move toward a future of autonomous vehicles of all types. Thank you.
Thank you, Dennis. Everything that moves will be autonomous, so that's really quite a statement. Let me now turn to the regulators. Coming from a very heavily regulated country, we are always wondering whether regulation is really to lead industry, or first innovation should happen and then really let the regulation come from that. So my question to you, Chris, is how will we transform the current regulatory systems which are in place for road usage to accommodate all of these kinds of autonomous vehicles at different levels as they come in? And second, how do you see these legal and insurance systems, again, adapting for these vehicles? And what will be the role of government in implementation and also in enforcement?
So with respect to the first question, really, I think the approach that we must take is, of course, really an incremental, almost baby steps kind of approach. At the end of the day, and maybe at the risk of quoting Donald Rumsfeld, we know what we don't know, we don't know what we don't know. So I think we have to take this baby steps kind of approach and figure things out as we go along. And maybe just to give you an example from the Singapore context, last year we amended our Road Traffic Act to really create this regulatory sandbox to allow for AV trials as well as deployment in Singapore. And the idea really is that with this sandbox approach, we can more nimbly adjust our rules and regulations to facilitate trials and deployment. And really, what this means is that now we have a set of rules already in place. We adjusted it to accommodate AV deployment, but maybe in about a year or two's time, when we learn more about the technology, more about the capabilities, but also the safeguards that we need to put in place, we can then quite nimbly adjust these rules again. And we have this sandbox for 5 years. At the end of 5 years, we have to go back to Parliament, either to extend the sandbox or to perhaps really enact new legislation. But within this period, we have that flexibility to change rules as things move along. So I suppose very quickly, that's the answer to your first question. On the second question, really, well, it's really something that I think that requires more conversations between industry as well as government. I certainly see government playing a large role in facilitating this effort. And again, maybe just to give an example from Singapore as well, the LTA in Singapore, we actually set up an insurance working group so that we hope that the insurance industry can be ready when AVs are ready for widespread deployment. So initially, I think there were some questions about whether this is really necessary, whether this is something that's really coming quite soon. But I think once we started briefing the insurance industry, they started getting more interested. And now the question on the table is really, how can insurers, for instance, get better data? And they're asking us, can the regulator provide this data? They're asking industry as well. And so it's a conversation that's ongoing. We found that the insurance industry, at least, has been able to strike up bilateral partnerships almost with individual AV companies. And through that, the companies maintain their IP, but the insurers also manage to get some of the data that they want. But all of this, of course, is through government facilitation almost, so that conversation can happen. And
Thanks. The message I got from that also is that it seems that the opportunities here are not just going to be around the automotive space, but really around the whole landscape. And you mentioned insurance in particular, and there's many others around it, which are all huge industries by themselves. So again, it seems that in all of these industries, there will be many, many opportunities for new entrants to come in and really change what's been happening, and the paradigm of the past will not work in the future. So I think, Patrick, let me turn to you. You're the, I understand, the finance person who's also looking after the investment. So let me ask you the difficult questions. I think a lot of the discussions around this topic revolve around the fact that while systems and computers are very good at following rules and orders, ultimately driving on the road is much more than that. And as all of us know, decisions have to be made in split seconds, and really sometimes with intuition, without the right amount of data which is available to us as drivers. And when you compound them with issues of moral authority, that really who decides at that split second whether you want to save the passenger or other road users when an accident is inevitable, and specifically in countries where the traffic is very, very chaotic, and typically the norm is that people will break the law rather than follow the rules. What happens then? So what is your thinking around all of these issues, and how as a company you will solve these issues at the same time where you're looking eventually to bring all the people in the system together?
Yeah, I mean, I think, one, it's a tough question, but I think it's the right question to be asking. I think the moral dilemma and the questions that stem from that, it's not a new debate, right? It's been around for centuries, since people were being put in cars and having to make these decisions themselves. I think, when we look at it, we think that there is no one company, there is no one actor that should be setting any, hard and fast rules. I think we approach it from more of a philosophical point of view of, this is going to take collaboration across, governments, across, pedestrians, the public, other companies. And really at the end of the day, I think there was a great article or research that came out in Nature recently from MIT where they had the opportunity to survey millions of people. And I think when I read that, my takeaway was, there is no right answer. There has to be a localized solution to the different countries. People drive, people act, to your point, in a variety of different ways across different landscapes. And so, I think the approach we're taking at APTIV really is a structured AI approach, whereby, there is the rules-based system where, we're even having partnerships with the Singapore LTA to kind of look to enact and change legislation to make rules a little bit, easier for the implementation of AVs. But then also on the more machine learning, we are doing it in a way where it's structured in the sense that we can explain the decisions that we're taking. So trying to bring some transparency to it and flexibility. And I think that that's really the key as we think about it going forward, that we can justify what action has been taken, and then we can learn and grow. And I think the 2 points that are important to underpin all this debate, because I think we can very quickly go into a big philosophical moral debate, but the promise of AVs is really to reduce the number of fatalities and increase the safety of vehicles. So we have to remember that, and at the end of the day, also I think we ask tough, challenging questions, in terms of the decisions that should be taken, whether there's two objects on the road, and sometimes we have to kind of put it into context that these instances are pretty few in the sense of they're edge cases upon driving if we just think about our daily lives. So I think it's the right context, and then I think it's collaboration.
And I think one of the things that we're seeing again is, well, based on what we've heard already, people are only going 20 kilometers an hour. So, but the reality is, like I said, there's all these edge cases. There's no way to test these in the real world. And as we're all driving around, we basically never see them ourselves. So even these test vehicles that are doing tens of thousands or millions of miles aren't seeing them. And this is where it really comes back to, how do you test that? How do we earn the trust of the public? How do we prove, even mathematically, that the systems are safe? And so I showed one very simple example of the simulation, but what we're doing is building out a system where we can test billions of miles in virtual reality. And we're able to bring in real maps, we bring in real city data, we can bring in accident data. It's an open platform to create a massive database of scenarios and be able to repeatedly test and test and test and iterate until not only do we just get it right, but we never get it wrong. So when we get to that point, then we can put it on the road and we know that it's going to work.
Thank you. Richard, let me turn to you. First, let me ask you, since you're from the UK, and if you're a betting man, would you bet on autonomous coming first or Brexit coming first? But
it would have been nice to get through a conversation without the B words coming out. I think we're seeing autonomy sort of trials rolling out now. It depends what you mean in terms of scale of autonomy. There are trials, trials in Greenwich. We've got AutoDrive, which is doing trials between Milton Keynes and Newcastle across many different types of roads, urban, highway, rural roads. This is here now. We're already doing it. I think probably post-March, I'm not going to use the B word, post-March 2019, we'll see an uptick in scale in there. The government, CCAB, launched a competition recently to incentivise companies to deliver trials of potentially of robotaxis or freight or other autonomous services which will scale and have a long-term economic model associated with them. And I think that's an interesting activity the UK government's undertaken to try and incentivise early delivery so we can actually see and learn from how these things will operate on the road, but more importantly, not just learn how they'll operate on the road, but how an economic model will support them longer term.
So, as a follow-up to that, and this is a question to all the panelists, I think this is one area where the question of open technology comes in, and typically all companies are very reluctant to share technology for obvious reasons, but for a transformation of this size and scale to happen, how do you think actually one can get companies to share their innermost data, their IP, because you have millions of people and many thousands of companies which are all working on different technologies, and if they don't talk to each other, obviously it's catastrophic. But how do we ensure that there's some kind of a system for sharing all of this data?
I think that's really, really important. And what we've created is an open platform, and I think so we're really trying to encourage that. We actually have over 370 different companies in the autonomous vehicle space that are using the NVIDIA Drive system. And so it's the core computing platform. We write a lot of software, and then everyone else is building their own applications on top. They're plugging their different sensors in, they're integrating their maps. And so we've tried to make it as easy as possible for many people to plug and play. I think we've seen on the mapping side now starting to form these coalitions and sharing of information among many of the automakers. I think we're going to see the same kind of thing happen with algorithms. There's a lot of data being collected, and eventually I think that data will be anonymized and can be used to test and evaluate. And the other thing we're doing on the simulation side is working with different regulators to essentially encourage the adoption of a virtual driver's license. But how do you know your autonomous vehicle works? Well, you have to run it through this simulator and be able to pass this battery of tests. And once we sort of standardize upon this, I think we'll see the industry be able to then feel much, much better about adopting these systems.
I think I'd just add, I think, we recently, out of the leadership from Autonomy, that as part of APTIV, they published New Scenes, which is really kind of a full suite of our perception data made available to the public. You can go, and it's for kind of development license as of now. But I think we'll see more of that coming across the industry, and I think that's a testament to the academic history and kind of heritage of some of our leadership that want to be transparent, they want to put it out there for people to learn. And I think to a point you touched on, when we think about the cost of validating cities to actually have autonomous vehicles from kind of the investment side, it's hard for me today to say that we could go and validate 10, 20 cities by ourselves. It's just it's a huge resource and capital constrained activity. And so I think to Danny's point, eventually I think we'll see more sharing from an economic perspective.
Just to add on from the regulator's perspective, I mean, we'll be talking to various companies as well about their take on this issue. And at the moment, it does seem as if there are different approaches. Right? So some companies are a little bit more closely held, others are more open. But I think I certainly see the reason why some of them are perhaps a bit more closely held. Because at this very early stage where the IP is really quite critical. So for them, I think these guys perhaps feel that they need to be a bit more protective. But I suspect it's a matter of time before I think everybody starts moving towards a more open approach. And one of the things that we convened recently was a workshop to talk about autonomous vehicle standards for Singapore. So we're in the process of finalizing a set of standards. So companies like APTIV was there and many others. And I think we were quite happy to see that companies were starting to, they opened up, they were ready to talk about standards and what they could do perhaps to even harmonize some of these things that we're talking about here.
But Richard, do you think these will be voluntary standards, or these will be standards which are then ultimately mandated by governments? Which way do you think the regulation will move?
I think it would depend on your jurisdiction. Where I think in terms of where we are in Europe, I think there will be a lot more certification guidelines come from the government. I think in the US, there'll be a lot more self-certification. But ultimately, I think what we need to be able to do is understand what best practice is across all of these environments and have sensible conversations around what are the parameters we're going to set here. I think the opportunity that connected and then autonomous provides right now, and sort of coming out of discussions I've had here over the last couple of days, is that perhaps we need to start thinking about what is acceptable driving behaviours and driving standards for different jurisdictions for humans. How do we translate that into autonomous vehicles, and how do they perform similar functions in different environments? One of the conversations we've had a lot over the last couple of days with Mobileye and others is, what is the acceptable, distance between vehicles? In the UK, it's a 2-second rule. It's a certain number of meters in Germany, but it's going to be different between different jurisdictions. But how do we measure that? How do we find evidence around that? And given what we've seen today with the data collected by NVIDIA and others, I'm pretty sure we can come up with an answer and say, the normal distance that humans leave between vehicles in New York or London or Tel Aviv or Mumbai is this. And at least then we have some data to talk about what is acceptable, what's the acceptable parameter for an autonomous vehicle, and why, as a regulator, would we set it to be 2 seconds, 3 seconds, 1 second. And that doesn't even include, different weather conditions, different road conditions, and all those other things within there. But you need to do something to have that, start that sensible conversation around what is acceptable for individuals and people.
So last, let me ask all the panelists. Israel is really a country of entrepreneurs, and we have many entrepreneurs in the room. So probably, what's the one area of opportunity that you would like to leave them with? This is such a vast space, and let's say if there was one area that you think will be where aspiring entrepreneurs can really look to make a difference, what would you say that is? And you can say one or two or as many as you want.
Say 3 things: data, data, data. The roadside, the vehicles, they are producing vast amounts of data. We're trying to figure out how we can open up the business models to allow that to be shared more flexibly between insurance, between manufacturers, between the roadside. But actually already today, talking to companies that are working out something, they're already forming relationships with telematics companies to provide information for simulation, for information for maintenance, predictive maintenance on the road, information for mobility as a service. That's where the real insight will come from. The question is how do we open up enough forms of data, enough sources of data that are useful for companies to share and build the emerging business models for the future.
So building on data, I'd add a word, data science. And essentially, you can have all this data, and we have data that goes back years, whether it's in the medical industry or energy or automotive. But it's how do you get the insights out of this? And so this is this whole new computing revolution with AI. And how do you build models? How do you train these models to get this insight out? So anyone who's in university now, studying computer science, I'd say focus on data science. Entrepreneurs, how are you going to leverage this new computing model? Again, for algorithms that go in the car, so if you're a software company working on those algorithms in the vehicle, or many of these other services, again, we can extract information, we can build new business models, you can create incredible industries based on AI. And finally, in terms of then the other peripherals, if you will, we're seeing incredible innovation coming out of Israel with mapping solutions, with new sensor types, whether it's LiDAR, whether it's thermal cameras, other kinds of information, even V2V. I think one of the earlier talks was saying it's essential. I think it's important. It's a really nice thing to have. It basically becomes a sensor that lets us see around corners, but there's so many barriers to that becoming widespread that we're not waiting for now, but when it does arrive, it'll be great. But again, look at opportunities for taking innovation in new directions, figuring out how can you leverage AI, and I think you'll be successful in it.
Yeah, I think that's a great summary as well. Probably not too much to add. I think, for us, we look at things that are going to enable the future, and I think, it's no secret we've invested in multiple companies in Israel on the perception side, but I think, still, outside of some of those areas, there's always room for evolution on the hardware to enable the solution. So I kind of focus on some of the perception suites, and then, I think in terms of companies that are trying to also innovate on the business model are very important for us. I think, as we think about ourselves as a tier one, we're always looking for ways that we can innovate on that side. And so partnering with entrepreneurs that have been able to prove that out and then helping them scale would be something that, definitely I'm interested in.
Yeah, so I quite agree with the other panelists. Just perhaps add that I suppose there's room to look beyond the immediate core technologies and look at the wider ecosystem and what AVs may bring. Maybe this is not a very good example, it's not a technology example, but when you think about it, with AVs you have the opportunities to really think about how you can redesign cities and towns. So what opportunities might that bring when you actually do things like that? So just about the issue.
Great. We have maybe time for one or two comments or questions from the audience. Yes, please.
You talked about sharing data, and sharing data is particularly important when there is an incident or an accident. Is there going to be a regulatory change to mandate exchange of data or revealing data in the case of an incident or an accident that
So what I think the question was, is if sharing data is really important. If there's an incident, how are you going to share the data? I believe that was the question. So the benefit of these AI cars is that software updatable, that at least within that fleet, right, they'll be able to get updates that will solve problems. Now, whether one particular car company ends up sharing that information with other car companies, I think is kind of open for debate. On the regulatory side, I'll let you answer that.
Important to say that Meridian is not the regulator in the UK, but in terms of observing the trends in the UK, I think, definitely that conversation is happening between government and industry. What data is available in the aftermath of an incident so that we can investigate it properly. I think there's something around how that's done scalably and how we learn how to do that, because potentially early on, the volume of accidents and incidents might be quite high, but it'd be great to see the number of incidents come down so that we can actually invest in sort of aerospace quality style investigations around incidents and accidents and share the results of those transparently across industries so that learning can happen and go from there.
One of the things, I'm from California, and so all autonomous vehicles in California need to be registered, and every company that runs these tests now needs to file reports, and if there's any accidents, then those obviously become public record. And so then there is this forum, at least in California, for sharing this information and seeing that trend data. And most of them are the autonomous vehicles either moving slowly or stopped, and they're hit from behind. So in and of itself, the other vehicles are causing those accidents, but then it points back to, is there some greater issue? Again, I think the industry can look at this trend data and make itself better as a result.
So in Singapore at least, perhaps again, depending on, I suppose it depends on the jurisdiction you come from, but in Singapore we adopt an approach where we require AVs to be outfitted with a black box recorder, so that in the event of any incidents, we're able to really go back to the black box recorder and retrieve data, and we can then reconstruct how the accident happened. Of course, together with our partners within the Singapore government, like the traffic police and so on, but also with the cooperation, hopefully, of industry as well.
Thank you, Chris. I think we have one more question.
Do you see, can you imagine any scenario in which an autonomous vehicle will have to relinquish control back to the driver, and what is the mechanism under which it will be carried out? Like, for example, in emergency, if the human inside declares an emergency or stuff like that.
Yeah, sure. So I think I can take this one. What's that? I think I gave her the question. I think the question is, in terms of, when, we have this kind of handshake between man and machine, and there's an event where the human needs to take back over control of the vehicle, how is that handled? I think that was the question. So I think there's a lot of ways that this is being addressed. In Europe, with NCAP coming out in the near term, there are solutions across in terms of, I think, eyesight. There's other kind of software solutions where there's going to be more of a controlled handoff between the machine and man, in the car. And I think as we think about L3 solutions, I think that is the right step forward. I think obviously the control, there needs to be, if the human cannot take back over the car safely, that there is rules in place to pull the vehicle over safely and kind of abort that kind of driving scenario. As I think we think about L4, L5, where steering controls are actually removed, and there is a medical situation inside the vehicle, for instance. Then I think it comes down to different solutions that are evolutions off of those Gen 1s. I think there's companies doing it out there, APTIV, kind of trying to, and as well as some other ones, but trying to really bridge that gap around, how does the machine actually cognitively understand the scenario which is occurring, and then what actions can they take? And I think that's really the point to your question is, the what's next. And I think that's where solutions are sprouting up, but it's an area that, I think is growing.
We're basically bringing AI in the car as well as outside the car, understanding the context of everything going on inside the car. Is the driver paying attention or not? But again, I think with superhuman levels of perception outside the car, we're able to anticipate much better than any human could, understand a full 360-degree context. And again, as we discussed previously, the systems aren't getting distracted, they're not drunk, they're not drowsy. So all those kind of dilemmas that you speak about don't even exist. I think the real dilemma is a human getting in a car when they shouldn't be driving and getting behind the wheel versus the decision that an autonomous vehicle would make.
So I just want to add, so we talk about safety a lot here, it's come up here, but the laws of physics still apply. The coefficient of friction between road and rubber is still a thing. Stopping distance will be a thing no matter how much we minimize that thinking distance from humans. And I think we all need to prepare in our minds that there will never be a zero accident future, or whatever we can do to minimize that, all the better.
So before we close, let me say that Israel, with its ability to innovate and disrupt rather than adapt, is really the best place where such changes can be imagined, engineered and led. I think the automotive industry is clearly moving to where profits are coming from not just the ownership of large fixed assets, which it used to be, but disruptive technologies and innovative solutions. And I think many of these can clearly come from Israel. All I can say is if this can be combined with the traditional markets of the West and the frugal innovation and the large domestic markets of countries like India, then we can have an unbeatable combination. Let me just end by saying that 1/3 of all American startups with billion-dollar valuations have an Israeli or Indian founder. So I hope we can replicate this in the area of smart mobility. So thank you to all of you for a patient hearing, and I think we've exceeded our time by only 1 minute, so that's not so bad.
And we shall continue. Well, the second pillar of smart mobility is the electrical vehicle. Before we dive deep into what it means to go electric, let's try and find out how electric can be smart.